Here is a nice and interesting number theory problem. It comes from United States of America, Olympiad 2013. So the question, exists AB as a natural numbers, satisfy these following equations. We get this equation and this equation must be cubed, both of them, okay? We have a similar equations. See, the only thing changed here, just the exponent. This one has B has a fifth power, the other one has a fifth power, okay? More normal, okay? So let's express that. Before we get started, I would like to remind you to do not forget to support the channel, like, comment, and subscribe, okay? Now let's go through the process to get the solution complete. So let's express that. So I get a b to the fifth plus 3, which equals cubed, x cubed. The other one, I will have b is multiplied by e to the fifth plus number 3, which equals y cubed, okay? So let's move over these 3 on both sides. So I get here, so I get a b to the fifth, which equals x cubed minus 3. The other one becomes b is multiplied by e to the fifth, which equals y cubed minus number 3, okay? Here is the thing. So in order to make the exponent the same, we need to join and combine these 2 equations together in order to get the same exponent. How to do that? I'm going to multiply this one by this one. This a is going to join this a, becomes a to the 6, this as well as this one, okay? So now let's do that. So I get here a b to the 6, which equals x cubed minus 3 factor y cubed minus number 3, okay? So it looks like you have a nice thing here. The best measure we can use here, mod 9, because we see x cubed and y cubed here. X cubed is always a congruent to minus 1, 0, 1 mod 9. I'm not going through the details. You can check by using the chart. So I have done this one before a lot. So this one, x cubed, is always congruent to y cubed. Cubed is a congruent to minus 1, 0, 1 mod 9. It's more known. So let's try this one. So also, if you check this one, always we get a is multiplied by b to the 6, which equals z to the 6, also is a congruent to 0, 1 mod 9. All of them, you can use the chart, you will figure out, okay? So always you get a reminder when you divide this one by 9, always the reminder 0 or 1, either one, okay? But now we need to check exactly which one is an appropriate 0 or minus 1 or 1, okay? So since we have a lot of possibilities here, which means we are going to check which appropriate reminder we can use to solve this equation, okay? So now we will have too many cases here. Let's work on this one. So I get x cubed here minus 3. So you know x cubed minus 1, 0 or 1. By subtracting minus 3, I get here x cubed minus 3 is always congruent to minus 4. Subtraction, we add in minus 3 in each remainder. So get minus 4 here, or minus 3 or minus 2. Similarly for the next portion, so get y to the 3 minus 3 is a congruent. This is mod 9. Also you get the same thing because you have a symmetry here, mod 9. Let's make this product. So we get ab to the 6, which equals x cubed minus 3 factor y cubed minus 3 is a congruent. Now here is the thing, we will have 9 possibilities here, okay? So when you multiply this one by this one, you will have this one multiplied by this one, or this one by this one, or this one by this one. This is 3 possibilities. The second 3 possibilities, which is start with the possibility number 4. So this one is multiplied by this one, or this one, this one, or this one. Or lastly, this one is multiplied by this one, this one, this one, and this one. So we'll have 9 cases. We don't know yet which one is will be working here. Okay, so minus 4 is multiplied by minus 4, which is 16. 16 we get 2 less than 18, which is minus 2 here as a reminder. This one is multiplied by this one, 12. 12 you get 3 more than 9. This one is multiplied by this one, you get as a reminder. So the fourth possibility, this one by this one, I get 12. 12, 3 more than 3, 3 more than 9. This one is multiplied by this, which is 9. 9 is 0, a reminder, because 9 divide 9. Lastly, this one is multiplied by this, which is 6. 6 less than 9, which is minus 2. Let's start with the last 3 possibilities. This one is multiplied by this one, which is 8. 8, we have 1 less than 9. This one is multiplied by which is 6, minus 2 here. Okay. Lastly, I get minus 2 is multiplied by minus 2, which is 4. So I get a remainder 4 here. So this is the 9 possibilities, but which match this one to have equality? We see only 0. 0 is a common remainder here. All others, none of those works here except 0, because we get 0 in both sides of this equation as a remainder. Okay. Now this one is telling us is a congruent to 0 mod 9. Now let's read the blue portion and work on this one. Okay. So we get a b to the 6 is a congruent to 0 mod 9. So it's telling us ab cubed, let's take the square root on both sides, is a congruent to 0 mod 3. So it's telling us 3 divides ab cubed. In the other word, 3 divides ab. Since 3 is a prime, okay, which means 3 divides ab. 9. This one is telling us x cubed minus 3 is a congruent to 0 mod 3. Okay, we get y cubed minus 3 is a congruent to 0 mod 3. So now you get 3 here, you get 0, which means x cubed is a congruent to 0 mod 3. Okay, it's the same thing. You can put it x cubed is a congruent to 0 mod 9 as well, or 27. Okay, because 3 always divide x here. So this one 3 divide x and 3 divides y. Okay, because 3 is a prime. Okay, always this one divide x. We don't care about the exponent. Okay, whatever the exponent is, in the end 3 divide x. Okay, also 3 divides 27, because if you raise the exponent, see, if 3 divides x, which means 27 divides x cubed. So when it's telling us 27 divides x cubed and 27 divides y cubed. We get here 3 divides ab. In the other word, 729 divides ab to the 6. Okay, let's do that. So we get 729 divides ab to the 6. ab to the 6 is the same as this product, which is x cubed minus 3 factor y cubed minus 3. So we know x is a multiple of 3, so we get 27 here. So let's write x equals 3 is multiplied by x prime, because it's a multiple. So we get here 729 divide x cubed, I get here 27 x prime cubed minus 3 factor 27 y prime cubed minus 3. Okay, take 3 out of these things to cancel out this one by 3. So we get here 243 divides 9x prime cubed minus number 1 factor 9y prime cubed minus number 1. Okay, area 1 divides this one because area 1 is a multiple of this one. Okay, because this one is a bigger, because we have big divisor, I'm going to reduce it to the smallest divisor. Okay, area 1, so it gets area 1, which equals 9 is multiplied by 9 divides 9x prime cubed minus 1 factor 9y prime cubed minus number 1, which means 9 divides this one and 9 divides this one. Okay, so but 9 divides 9 is okay, but 9 cannot divide 1 as well as this one, which means it's clearly it's a contradiction, it's impossible. So what we have done here, and we work on those equations and we solve those equations, but in the end we find it's impossible to have a solution for this equation. So which means there is no exist AB satisfied these two equations. So I've done this problem. Thank you for watching. We'll see you next video. Bye.